All right, it's 1 o'clock here, so we'll get started. Hi, everyone. My name's Eric. I am the demo technician with Bobcat Cam. I normally do the demonstrations of the software program for potential customers. I also am doing training sessions as well, online training for any customers that would like to book 1 or 2 hour sessions at a time. They have a part file that they'd like to go over, and we can program that with them from square one and get all the way to a G-code file to test on their machine. And I'll get over to our software program here. And doing webinars here as well as part of training, also part of tech support, answering any questions that you guys may have in case you get stuck in the software program along the way there. We have our technical support phone number and email address in the chat there. So if you guys have any questions, call or email us with any questions there, and we can help you out with a software program. And yeah, doing the webinar today, we'll be going over advanced roughing features here with this part file that I have on my screen, and also going through different methods to control feed rates for your tooling. And so we'll go here to the cam tree. Got a lot of stuff blanked out here. I'll keep it all blanked out, and we'll start from the beginning of how to start programming this part file here. Sort of an assembly. So if you have multiple solids, like we do here in this part file, and you could bring it in as a step file, you could bring it in as a SolidWorks part file, essentially, IGES file, any of those solid model generic file types there. You can go to Utilities, and you can go to Translate, and you can manipulate each of these solids exactly to how you need with your assembly there, you could say, as you would have on your machine. So you've got the vise and work holding pieces here. You can select one of these solids here in the translate function, and you could move it back and forth in X here. And you can also type in the number in X of how far you want to translate it over. If you wanted to move it out and part come down on the clamps, or if we're bolting it in like this, essentially. So we can type in that X amount there, a couple inches, and move it out. And then we also have the functionality in our translate function where I can select a solid. I can pick my start point of translation. So instead of translating it from the center of the geometry, we can pick where we're starting the translation. So pick one point, and then picking the end point of where that translation is going to finish off at, let's say at this location there. You could say, like in SolidWorks, those 2 points would be coincident, you could say. But yeah, that's how you'd be able to sort of setting up, another term in SolidWorks is setting up mate references, so that you're mating the 2 points together there at a certain location to make them coincident. You could set them at a certain distance. You could always translate the geometry out a little bit in X, Y, or Z after that. You could do an angle direction if you went into Utilities and rotate the solid model from that location. So yeah, all of your different mate references can be found. We don't call it that, but that's the same methodology we would use in Bobcat to set up your assembly file here. So I can undo a couple times. We've got our solid model that we import, and we'll get right into the machining process here. So we'll go to the top and go to Cam and go to a new job, and it'll be a milling job type. We also offer turning for lathes, mill turn for lathes with live tooling, and wire EDM machining. Under the milling job type, under the milling machines, we have our 3-axis mill. We also offer laser, plasma, water jet machining included in the milling portion of our software program. We also offer 4-axis milling and 5-axis simultaneous milling as well. So we'll select our 3-axis mill, and we'll go to the stock wizard to get to the next page here. And then we can define our workpiece here so that we could see that in our simulation and make sure everything is cut to size there. Go to our next page. And our next page is our stock that we're defining. It could be a rectangular shape of bar stock. It could be a cylindrical shape if I click on that one here. It could be extruded out from wireframe, or I could select an existing solid or STL model as my stock that I'm using, or a revolved piece of stock. This is normally used for turning if we have a turned piece of stock that we want to use. So we'll go to rectangle and we'll hit calculate stock. It'll create a bounding box around my workpiece here that I had defined. I can go to setting up the dimensions if I want to change it at all. If it's a little bit larger than 7 inches by 5 inches, I can type those numbers here. And I can type in the thickness of the stock in the Z direction there if it's anything taller than that. Then we also have our offset options here, plus or minus. So if I want to only add, and I'm sort of going to revolve it around so that I can see my X, Y, and Z locations in this direction here. We have our offset plus in X. So if I added an extra inch in the positive X direction, you can see the stock will gain an extra inch on that side there. So those offsets can be useful if I want to add an extra 100 thou on the top of the part, for example, to do a facing operation. I can set it up there. And that way, when I go to the next page, we have our machine setup location that we're setting. So if I'm touching the tools off or using a probing tool at this bottom left corner, for example, I would first highlight this box under origin for my coordinate system, for my work offset, and click on that point as my new work offset for my G code, for simulation, everything like that. So that will be X0, Y0, Z0 in the G code. If I wanted to put it on a certain side here, let's say, if I revolve it over and let's call this our front face right here. If I'm doing a drilling operation on this side, for example, I can click on a point as my new G54 work offset, say it's rotated 90 degrees. I can set my X direction with a point or a line going in that direction. My Y direction, click on a point or a line parallel to that Y direction there. I could even go over here and click on a parallel line. And I can also flip the directions here with the reverse direction button here. If I wanted to reverse the Z direction here, I can flip it that way. Same workflow as if you are setting a coordinate system in SolidWorks. We also have options of setting coordinate systems here in the same manner. And so then I can click OK. And I'm going to get rid of that milling job and go to my existing milling job that I have in this part file already. And so I'll expand the milling job here. I got a bunch of different features in here, where a feature is basically just a group of operations. It could just be one operation like this one here with my first facing operation here. And then we have our 3-axis toolpaths, roughing, finishing the pockets, a Z-level finish along the walls here and the tapered surfaces, finishing the flat areas here. And then we have a few other operations we can go through as well, some surface-based toolpaths that are included in the 3-axis premium package there. So we can take a look at differences between the different 3-axis milling tiers that we offer. All right, so we've got the part file here. Let me know if you guys have any questions so far in the comments section. But yeah, we basically just went through defining our stock. You can see it transparent right there in blue around our workpiece. We defined our machine setup. It's right on the center of the stock there for this one. And then we have also right below the machine setup, before I go through any milling operations, I want to highlight this fixture option right below here. This is a newer option here where we can define our fixture, and we can see that in our simulation. And so now we can go to the milling operations. We can right click on machine setup 1. We can go to our different milling operations here. We have drilling and tapping operations. We have probing. That could be a cool webinar to go over in another webinar, where we could use a probing tool, either a contact tool or non-contact, I believe is the terminology, to use a probing tool to touch off the corners for your work offset, and also for verification. For example, with these pockets, we can use a probing tool to go down to the depths of the pockets and the sides here, make sure everything is cut to size on the machine. We support Renshaw, Bloom probing software there, and a bunch of others, but those are the two main ones that we focus on, and we've proved out the G-code for those probing tools. But yeah, anyway, we'll go back to the machine setup, right click, and again, probing, got drilling and tapping, counterbore operations. We've got our mill 2 axis, which we'll quickly go over under the machining strategy page. We have all of our available mill 2 axis features. This is in our Mill Express package that includes all of these operations, and it is considered 2.5 axis milling. We have our available operations here on the right hand side that we can utilize: profile roughing, a profile finish pass, pocket, going down straight walls, facing, engraving, chamfer mill, and corner rounding operations. We have for plunge rough. I've never really used this, but if you use an end mill to plunge down to rough out some stock, we have that functionality as well. And drag knife we offer for vinyl cutting machines. And we also offer profile cutting and engraving for laser, plasma, and water jet machines as well. So we will go to we'll just go to this profile finish just to show you guys the differences between the different packages of milling. So our mill 2 axis, the tool is going to come down in Z, and then it'll move around in X and Y. That is our 2.5 axis machining options. It's not going to move in X, Y, and Z simultaneously. So just a brief description of our mill 2 axis here, and then our mill 3 axis that we're going to get into today mostly, where the tool, you can see in this toolpath, will follow along the curved surface, moving in X, Y, and Z simultaneously to follow along a curved surface like this. Now, before we get into the 3-axis milling, David, is there collision detection for fixtures? Yes. So if I have defined my fixture like I did, you'll be able to see it in simulation. And if there was any collisions in simulation, it will throw an error and let you know. So yeah, good question. That is a great reason for defining our fixture here, to view in simulation and make sure any collision checking there. So what I started with actually was a 2-axis mill feature with the facing operation, just facing down the top of the stock there. And then we can take a look at this next tool path in 3-axis. It's going to get down to each Z level here and rough everything out in a couple passes. And we'll get into that one. We'll first go to the machining strategy page and look at all of the 3-axis pro tool paths that we offer. So we offer this advanced roughing, where it'll rough out everything that it can with the tool path, with the tool selected for this one. Z-level finishing, the advanced finish, where it'll follow along surfaces with the tool selected there and finish everything that it can along tapered walls. Flatlands is where you can use a flat end mill and mill any flat areas, any horizontal flats there. Planar tool path, just going back and forth, planing across. Equidistant tool path, this is where it'll run around the boundary there and offset to the center, giving us a better surface finish. Pencil mill to mill any fillets. Project curves, where we can project a 2D shape onto a 3D surface, doing a 3D engraving operation. And then we've got this newer option here. I believe this started in V35, maybe 34, I'm pretty sure it was 35, where we have this steep shallow option where it's basically, we'll kind of take a look at it real quick here. Under the steep shallow, it offers Z-level finish along any tapered walls, but the Z-level finish doesn't do any vertical or horizontal flats, any vertical walls or horizontal flats. So this strategy offers sort of like a 2-in-1 here, where you've got a Z-level finish and an equidistant toolpath, as sort of like spiraling around flats there, or you have the Z-level and the planar toolpath for the flats to go back and forth across the flats. So we can take a look at that one a little later as well as another finish operation. It'll save you time, again, sort of like 2 operations in one, instead of doing the Z-level finish and then doing like a flatlands or a planar toolpath for the flats. You can use that steep shallow operation. So we'll get into the roughing operation. So we did the advanced rough here. This is in my current operations list in this feature. This is the only operation I have in this feature, and if I wanted to add more, I can go to my available operations. Say I wanted to add a finish operation, I can add that in with this arrow here after highlighted from my available operations, and then I can sort them with these 2 arrows down here if I want to move it up or move it down in the list of operations here. And if I don't want any of them, I can highlight them here and delete them here as well. So we've just got the advanced rough now. We'll go to the next page. We have our work offset number. Number 1 is G54, 2 is G55, 56, and so on, if you're setting multiple work offsets at the machine there. Multi-axis post, we normally recommend not to mess with this at all. This is tied in with the post processor, so we always recommend you contact our post processor department before messing with anything in here, setting limits and setting axis limits, things like that, rotary axis limits and all that. So we'll get to the next page. We have a standard UI, standard user interface, and we have a new advanced user interface, which is very similar to all of the tabs that we have in our premium toolpath options. And we can go over the advanced UI a little bit later there. So I'll use the standard user interface for now. And the next page, we get to our tool page. So we can define our tool here. We can easily just change the diameter, corner radius. If I uncheck this system toolbox, we can go to the dropdown and modify our tool as needed here. Or we can use system tool, which is a tool selected from our tool crib. We can also use different feeds and speeds, so we can use a different spindle RPM, a different cutting feed rate, and a different plunge feed rate. If I check this box, use system feeds and speeds, it'll go back to the default settings for the tool and the material that I'm using. So if I finish this out and go to our material library, that's located under the stock here. So if I expand the stock here, you can see this material library that I can double click on. And whether we're machining from carbon steel, aluminum, different types of plastic, we have material types already in here that I can select, and we have, you could say, recommended feeds and speeds. These are pretty conservative numbers. We recommend that you contact your tooling manufacturer to make sure all of these numbers are dialed in for your specific tooling and the material you're using. Don't want to break any tools and want to make sure you have the most optimized feed rates here. So if I select one, let's say I was at aluminum, let's say I was using carbon steel, I can use that one here. And then when I go back to that operation on that tool page, you can see that the feed rate has changed based on aluminum to machining carbon steel with this tool. I'm going to uncheck this box and use the, it does not change it back to where I was, but I was somewhere around 5,000 spindle RPM, 80 inches per minute cutting feed rate, 40 inches per minute plunge feed rate. I can change those at any time there. Then at the top of this tool page, again, we have our tool crib. So I can click on it. I can set up the tool holder and the tool here. You can see down at the bottom here, this is our tool library, sort of a newer option in our V36, where it's all on one page now. So I can sort by diameter. Start with the 3-inch insert face mill here, going all the way down to 1/32 inch end mill. And all of these tools are preloaded in the software program. If I want to modify, I can double click on one of them. If I want to add a new tool, I can create a new tool here. I can delete any of the tools I don't need. And then I can also either add it into the tool library this way with this arrow, or I could also highlight it and drag and drop. This is what I normally do, is I'll drag and drop the tool into the tool crib so that when selected, it'll be my new tool here on this tool page. Makes things a lot easier than making sure I've selected it. I've clicked that arrow each time. I just drag and drop it in. I'm going to cancel out so I revert back to the old settings I had there. So yeah, that's a good side note there. If I cancel out, it won't save any of the changes that I've made within the feature. If I hit finish, it will save all of the changes that I've made, but won't recompute the tool path. So if I've changed the tool and I've hit finish, it won't compensate for that tool yet until I hit compute. The big reason why we have those two differences of finish and compute is if we have a bunch of different operations in here, when we're getting into the 3-axis operations, it'll take a while to compute some of these operations. So that way, when I have just changed maybe just the one tool here in this roughing, and I've got a couple other finish operations I don't need to compute again, I can just hit finish, and then I can expand the feature here, again, this group of operations, and then I can right-click on the operation and individually compute each operation so that I don't have to compute every single operation in that feature again. I can just go into the CAM tree, compute that one tool path individually there. All right, so getting into a lot of stuff there so far. If you guys have any questions, again, let me know in the comment section. Sort of monitoring that at the same time here. Let's see. Go back to this cutting feed rate that I want. I want to make sure that I have all of these numbers set to what I normally wanted. That way, when I go into simulation, based on the cutting feed rates that I've set here, it'll give us our estimated cycle time. Those are pretty good numbers, pretty accurate numbers with the estimated cycle times in simulation. So then here I am setting up the feeds and speeds, setting up the tool number, and I can go to the next page here for this roughing operation. We have functionality for 5-axis with this if we needed to index to different locations and rough it out. And then we have our different cut patterns. So I start with parallel, where I can zig or zigzag back and forth inside of the pocket here. I can offset. So we have our offset out. It'll start from the center and work its way out. Offset in, where it's the opposite. It'll start from the outside walls and work its way in. And then we have our high-speed machining operations. This is where we're getting into controlling our feed rates and controlling certain things here. We have our high-speed machining options, which would be our morph spiral. The tool is going to start at the center, continually spiral its way out, keeping constant tool engagement instead of wasting time in those first 3 here, stepping over each time and wasting time that way. It'll continually spiral around, constantly engaged in the material. And then adaptive roughing, again, constant tool engagement, another high-speed machining operation, where normally with these two operations, the methodology is the tool will come down at usually the total depth when you're getting into softer material, going down to the full depth and just hogging out material as best as possible there, best optimized cycle times, things like that, and keeping constant tool engagement. Now, this tool path, if you are familiar with Mastercam or other CAM software programs, they call it dynamic roughing or dynamic machining. and our terminology is adaptive roughing, but it is the same exact toolpath, high-speed machining toolpath that you'd be used to there. Now this is a zigzag toolpath that I've set going back and forth. We also have the zig method, one directional method, where you can see that once it gets to one of the walls, it'll retract just a fraction of an inch and rapid back across to the next pass with this what they call trichoidal milling. So just to show you, we offer all of that functionality there. And then from there, we can go to our next page. And then we have our depth of cut. I've set it a 1/2 inch. Step over at 120. You can take a look at the intermediate steps. Sort of hard to explain without looking at simulation, so we'll have a side note of that as well. Allowance, we're leaving 18 thou for the finish pass to clean up. A little bit of material left over for the finish pass to clean up there. Our next page, where we can plunge down into the material, we can ramp in, or we can do a spiral ramp in, where it's basically a helical interpolation into the material to start with, using the side of the tool more. If we want to use the full side of the tool, entering into the side of the stock here, where there is an opening that we can start with, we can uncheck this box center cutting tool. And what this will do is it will have the tool start outside of the stock and work its way in with the side of the tool. Instead of using the center of the tool to plunge in, it'll use the side of the tool to do a side roughing routine there. Then our next page, we offer an option for machining flatlands. So this is sort of a flatlands operation included in here, where it'll come back if it doesn't go to the full depth here, for example, it'll do an additional flatlands operation. We also offer rest roughing, or what they call rest machining, where if we had a previous roughing operation, the software will calculate based on the tool I set up here. So if I had a larger tool, I set up the tool diameter and corner radius, the software will calculate what areas the previous tool couldn't fit into and calculate that tool path. So essentially it's going to start right where we left off from the previous operation and avoid any air cutting there. And we'll uncheck that box because this is our first roughing operation technically, other than the facing operation. We have linking for each step over, our gouge check page. So this is making sure the tool and the tool holder does not gouge into our workpiece. And then again, just as a side note, just to reiterate, we have that fixture option, so we can select the fixture and make sure the tool avoids that fixture as well selected. And then our next page, advanced feed rates. If we had if we're not able to set a rapid rate at the controller, we can convert all rapid moves to feed moves and essentially set that rapid rate here. We have our feed rate for linking, so where it's linking between groups of geometry. I can set up that feed rate here to speed up that process of linking between groups. And then we have adaptive feed rates. So we have radial chip thinning, we offer that. And we also offer what's called adaptive or volume-based feed rates here. This is where we're getting into controlling feed rates a lot more. So we can set up a minimum and a maximum feed rate. If I go back to the tool page, we've got that cutting feed rate of 80 inches per minute. If I go back to the advanced feed rates here, I have a minimum feed rate that I've set here of 10%. So for example, when the tool is getting into larger material at a time, like into these internal corners, for example, the tool can slow down all the way down to 10% of the feed rate, so all the way down to 8 inches per minute, somewhere between 8 and 80, keeping a constant chip load, and that will reduce chattering at the machine. So we have a minimum feed rate to slow down in the corners, and that's based on the volume per tooth of the tool. And then we have maximum feed rate if we're going on the outside, for example, cutting smaller amounts, smaller volume of material per tooth, it'll speed up that process up to 150% of the feed rate I've set there. And so from there, that is 150% from 80%. That's what, 120 at maximum there. So then from there, I can go here and we'll take a look at the two simulations. So I'm hitting post no on each of these. And I'm just looking at the facing and the advanced roughing there. And we'll take a look at the simulation there. And I'm going to hide the machine there. And we'll take a look at simulation there. I'll go full screen if I can do that here. There we go. And while I play that, I'll let you guys ask any questions. See if you guys have any questions about the facing operation and taking a look at the first advanced roughing operation we're looking at here for now. Speed up this process a little bit here. So yeah, as you can see in the simulation, it has the fixture down at the bottom, has a roughing operation. And as I restart and go to the next operation after my facing, we can take a look at the roughing again here. And once it gets down to the bottom, after my 1/2 inch depth of cut there, at each step there, you can see that it comes back up with a couple of steps up there. You can see 3 additional steps. That is our intermediate steps option. So once it goes down to the full depth, instead of having all of this additional material to be finished, it's going to add sort of what they call stair stepping as well. It'll add additional steps there in the toolpath to clear out a bunch more material there for your finish operation. Alrighty. So then, other than that, we'll close out for now. We'll also take a look, if I can show it here, at the top right corner right here where my mouse is. Says it will take about 8 minutes and 50 seconds based on the facing operation and the advanced roughing operation that I did there. And yeah, we'll get into sort of your question there, David. A nice feature would be when changes are made to an operation, the operation has a warning flag. Now, we don't necessarily have that for when we have finished and there's not any unsaved changes or any save changes, you could say, that need to be computed. We don't necessarily have that. That's a great idea, though. But what we do have, for example, is it under our edit toolpath, we have something like that. So if I expand the feature, I right-click on the operation, we can go into our edit toolpath option, about halfway down there, or halfway up. And then we can delete any toolpath here. We can trim and relink. We can also move the toolpath. So if I try to remember where the entry is here. It's going to be somewhere on this side where it starts from the outside, works its way in, probably right here. If I don't know, I can just cancel out. I can right click on the operation and backplot first to see exactly where I'm starting. Okay, so I'm starting right here where that arrow is. Close out of backplot, right click on the operation again, go to edit toolpath, select my entry here, and then I can move it even further off the part. For example, if I go to move, I can type in the amount here. So if I want to move it over in X a couple inches, type that in, 2 inches in X. Oh, it's actually going into the part. So I actually want -2. I can also drag it over. So if I click drag, you can see it'll create this coordinate system that I can click on, and I can move it around exactly where I want to here. Maybe to sort of ramp in and then move over. And once I click OK, that'll be applied. So I can backplot that. Starts at an angle coming on in there. And then you can see under that feature, on that operation, it automatically locks for us. It has locked because I've made some changes in the edit toolpath feature. And also we have it highlighted in red, showing that it is not the same as what we had computed originally. So if I want to go back to the original, I would have to right click. This is sort of a safety option here. We can right click on advanced rough and we can lock unlock operation. So that's one feature that you could use there, as you were saying there, David, sort of flag it as locking it so that you can't make any more changes to it until you unlock it. And then I can compute the toolpath again. You'll see that the highlighted red advanced rough will go back to black, showing that it is the original toolpath again. So that's a good feature to have too. Like sort of like you were saying, we do have the lock unlock operation. So if we don't want to make any more changes to it, we want to make sure, don't make any changes, don't recompute the toolpath at all. Just lock it so that it stays put until you unlock it. But it would be good to have sort of like a flag on the feature or the operation saying, hey, this hasn't been recomputed yet. Are you sure you want to maybe compute since you only hit finish? That's a good idea too. All right, let me know if you guys have any more questions in the comment section there. And we'll go to the next feature here. And I can highlight it. I can highlight the operation to show it there at any time, even though it's blanked out. I can show the toolpath just sort of temporarily there and see that it's the pocket operation there. I can go in. I might want to change this up a little bit because, yeah, I'm spiraling into this one, but I'm also spiraling in this. I could start from the outside. I can right-click on geometry, and I can reselect. So when I'm reselecting the geometry, I'm not going to change anything with it. I select the two surfaces there. But just to show you, we do have this checkbox under our selected geometry, detect open edges. So if you guys are familiar with the older Bobcat versions, if you're one of the OG users of Bobcat, something from like 31 or 32 and older, you would have to create wireframe for your pocket and create a dashed line for this opening to do a side roughing operation. You don't need to do that whole process anymore. You can just click on the surfaces of the solid model, and then you can check this box, detect open edges, and it'll do that side roughing routine for you automatically. So that's a really good one to have. It might not do it for me with that spiral entry. So if I go in, I'd have to probably change it to plunge possibly. Yep, and there you go. There's your open pocket from there. Right. Or maybe it doesn't, maybe it won't let me with that opening. But yeah, that is your open pocket routine there. Instead of having to create the wireframe again, create dash lines for your opening, you've got detect open edges now. Yeah, David, from version 17. I've only opened version 18 and 19 a handful of times, and I know how user-friendly and quick and efficient, simple it can be. I normally show the job templates. That can be one setting to use to make it as efficient as those older versions there. But yeah, anyways, that is our pocketing option there. And I'm just going to go back to spiraling to enter there. And we'll go back to the feature. We just did a pocket. We started our top of feature. If I pick top, I'm starting the top of feature at the top of the pocket here so that we avoid any air cutting from above that location. Our pick bottom, just pick the bottom of the surface edge there. Kind of hard to select there. So to make sure I'm selecting the surface edge, I can always hide the surfaces by clicking anywhere here in the background. And I've got some shortcut keys on my keyboard. S as in solid to show or hide the solid, and then I can easily click on that surface edge. T for transparent to show or hide it in a transparent view of all the solids. W for wireframe. And F as in foxtrot. If I'm somewhere out here in space, I can't find the solid anymore, I can hit F as in foxtrot to zoom to fit to screen. So I can fit the solid back on the screen. That was F as in foxtrot. That's a key that on the keyboard I use a whole lot. But other than that, yeah, those are some good ones there. You can always change those shortcuts by going to the top and going to File, going to Settings, and going to Customize Shortcuts here. All of your operations, undo, for example, is your Control-Z. If you needed to change anything, you can always click on one and add a new shortcut key here. All right. Let's see. So we got the pocketing down there, and it was, same as what we did for the advanced roughing, where we're selecting our tool, and then we're defining the certain cut pattern. Step over, step down if we're doing multiple depths of cut there, setting an allowance, leaving 15 thou for the finish pass to clean up, spiraling in, all those good stuff there. Okay, and so we'll show that all as well. Get down to the next one, our Z-level finish. So if I expand that one, we're just doing a Z-level finish in this feature here. Again, setting up our tool, starting from the top, working our way down with this finish operation, setting our depth of cut, and all the same settings as in with the roughing operation there. We'll hit finish, don't have to compute that again. And then I have this post yes no. So these two features here in my simulation you saw were turned off. We were only doing the facing and the roughing operation. We can blank or unblank toolpath to show or hide toolpath here. And then this option post yes no is for posting the G-code and also posting the toolpath in simulation. So you can see this icon of a controller with a red X. With this icon showing, it's not going to simulate and it's not going to post the G-code for those features until I turn it back on. So that's post yes now, and then if I click on it again, that's post no. It's your post yes no options. We'll go back to, so from the Z-level finish, we're going to go down to the next one, where we did a flatlands operation on just the flat here. And yeah, just same old, defining our tool, defining the cut pattern, and setting up step over, all those settings there. So I'll turn that one on as well. And yeah, just to go back to the original roughing operation, if we go to parameters, this is where our intermediate steps is. We can do 3 additional passes, working our way back up after we've gone to the total depth of cut. It'll divide that depth of cut, that 1/2 inch, by 3 and do 3 passes in between each depth of cut there. That's what we're looking at there in our simulation. Now you can see it shows the spindle, it shows the platter and the trunnion here of the machine. If I show the machine housing, it shows everything here with the machine that I have. That may not be in your specific Bobcat version, because this is in our Machine Simulation Pro. Now the Machine Simulation Pro is included in our 4 and 5 axis milling packages by default there. In the 3 axis, you do have to add that on. And I gotta hide the machine to be able to see the other side of it here. I could always turn it off by dropping this down and just showing the workpiece and the stock. There you go. And I can show just the fixture right here up at the top. If you don't have that Machine Sim Pro, you can always show the fixture still. And so we'll restart and hit run. Facing operation, roughing operation. Finish operation with the Z-level finish going down the tapered walls. And then we'll close out of simulation. Let's see. Trying to think of other settings here in the 3-axis Pro we could go over today. If you guys have any questions with the 3-axis Pro, please let me know. We'll get into, we can take a look at the 3-axis Premium as well. Some of our surface-based toolpaths that I normally show in a demo here. So again, we've got a Kurt Weiss as our fixture, and we've got the soft jaws, our stock, machine simulation. We did an advanced roughing operation again, starting from the side, working our way in. And then we have our finish operations here. Yes, David, with the Machine Sim Pro, it will detect any components with the machine. If there's any collisions, it will throw an error for any sort of collision check there. That's a good question. And it's all based on how you define each of the parts in your assembly of your machine there. And so from here, we've got some finish operations. So this is our first premium toolpath that we can look at today. We would right click on the machine setup, go to Mill Multi-Axis. And under the surface-based toolpaths, these are our surface-based toolpaths in the 3-axis Premium. So we have parallel cuts, following down or across any surfaces there. Cuts along curve is the first one we're looking at here, where our geometry selection would be the drive surfaces would be the top 2 surfaces here, and our lead curve is the where the toolpath will go perpendicular across that direction there. We set up our tool, and then we set up the parameters. This is exactly what you would be seeing in the advanced user interface in the 3-axis Pro toolpaths as well, in the 3-axis Pro, where you can set up your geometry, you can set up your tolerance level, set up your maximum step over. And what I like in here, in all of these premium toolpaths, you can set up a step over, or you can set up that step over based on your desired cusp height. Some customers I've heard call it a cusp height, a scallop height, or basically the specific tolerance level left on the surfaces there. So if we want to get down to 1/10, 1/10,000th of an inch, I can type that number here, and you'll see that the maximum step over will calculate according to the desired cusp height right there. So I don't have to go into simulation and have any guesswork there, guess and check, check the surfaces and check the tolerance level. It will have the tolerance level for me set up with that step over calculated right there. Those two numbers that are related to each other. Set 1/10 there for my cusp height, and it'll automatically set up 12th thou for a step over. Over here on the left-hand side, we also have extend and trim. So if I want to extend out the toolpath a little bit past the surfaces, I can set that here. If I want to trim it back a little bit, I can set that number here as a negative number. And then we also have side extensions. So if I want to start a little bit before the stock and work my way into it, and then do a couple passes additional afterward, I could do that here as well. So here's the advanced user interface, how it looks, different tabs up here at the top. So this is our surface paths, or sort of our geometry selection. Our next tab here would be our tool axis control if I'm doing 4 or 5 axis machining, or just leave it at 3. Our next tab here is our gouge check page. Make sure the tool in the tool holder doesn't gouge into our workpiece. We have linking for each step over, where I can set up my lead in and lead out. And I can set up linking if I want to go up to a specific clearance plane where I'm linking between groups of geometry. We have a roughing tab here, where I can set multiple passes here. If I'm getting down into a channel, I can do number of roughing passes, how far they're going to be spaced out, number of finish passes, and how far they're going to be spaced out. And then our last tab up at the top here is utilities, some miscellaneous stuff for setting your rapid rates and things like that here. So that is the first surface-based toolpath we can look at. Our next one would be morph between two curves. And if I expand the geometry selection here again, it'll show me under the morph between two curves for this one. You can see the surfaces I've selected, the upper edge curves, so where I'm starting my toolpath, and then where I'm ending this operation as well. And you can see the toolpath here, it'll do a larger step over on the outside radius here, and then a much smaller step over on the inner radius to give us the same cut tolerance all the way down the part there. So that's a great way of optimizing our tool paths so that we don't have to do multiple passes on the outside, and we don't do too large of a step over here so that it's cut to size at the bottom, and is also cut to size at the top without having to do too many passes that we don't need. So that's our morph between two curves. You can see this geometry selection. It's not exactly a planar toolpath. It's not going back and forth in a linear motion. It will morph the toolpath, hence the name morph between two curves. It'll morph the toolpath between the two edges of the surfaces I select. From my first surface edge I select, it'll start right along that, run across, and then morph the toolpath out to the outside last edge that I select there. So it'll give you sort of a profile pass on each side there and give you a very clean toolpath all the way across. And then we set up our tool, and all of those same options as before, setting the step over, desired cusp height, tool axis control, gouge check, linking, roughing, all those settings there. So that's our morph between two curves there. Next one will be I believe it's another morph between two curves, but we can take a look as the other surface-based toolpaths in the 3-axis premium here. Parallel to multiple curves, we select some surface edges, it will do a profile of that, and then it'll create an array of that toolpath all the way outward. So instead of morphing the toolpath from one to this last edge here, it's just going to create that same toolpath all the way across it. Project curves, this is the same project curves to a 3D surface as in the 3-axis Pro, but this also offers 4 or 5-axis machining. If you wanted the tool to stay normal to this surface the whole time, you can do that here in project curves. Morph between two surfaces, so if we're going down into a channel, you can make sure that it's not gouging onto the sidewalls there. Parallel to surface, so again creating an array of the toolpath outward from surfaces we select. And flow line. The morph between two curves and the flow line, they both support undercutting. So we could use a lollipop tool to finish this surface and do an undercut there. So yeah, we'll take a look at the toolpath with this one, the simulation here. And let me know if you guys have any questions with the 3-axis Pro toolpaths that we saw in the previous part file and the 3-axis premium toolpaths that we saw in this one. And again, so if I show the workpiece or show the fixture, it'll show here, show that Kurt Weiss. Actually, I can define it here as my fixture. You can see here under fixture, there's a red plus next to it. If there's a red plus next to any of the selections here, like geometry, 2D containment, gouge check, you can see there's some red pluses there. That means there's nothing assigned to it. Nothing selected yet. So I want to select my geometry here for my fixture options there. My solids for my fixture there. And then we can go back to simulation and turn that on. Turn on the fixture, hit go. Here's the roughing toolpath. And again, this is another one where it has the intermediate steps and 3 intermediate steps at each one. So it's going down, I think, a 1/4 inch depth of cut for each one. And then it'll come back and do 3 intermediate steps along each one. Because this, if you look at the top step right here, this would be a whole lot for the finish pass to try to clear out as a finish operation. That'd be way too much material to cover with the finish operation with a ball end mill. So what we can do with this roughing operation, instead of doing a second advanced rough, we can do this intermediate steps option and do 3 additional steps, having the tool work its way back up, doing this stair-stepping routine to save us time with the roughing operation there. And that's a lot less material for that finish tool to cover there. I'm going to move myself out of the way here, because in the bottom right corner I can show you a couple other options in simulation that can be really helpful as well. So once everything's finished up, we have some verification options. In the cut simulation here, so down at the bottom right, we have these different tabs. This green tab for analysis, we can drop this down. Actually, sorry, we want to go to, which one do we want to go to first? We want to go to this red tab first for measure. And with this drop down, we can select certain points. So if I click on a certain point with my scroll wheel, it'll identify what the deviation is here and the tool number that it used and all of those settings. So if there was a certain deviation we want to get down to, We can make sure the deviation is just right there. We can also go to our Analysis tab, and we can go to this drop down for deviation. It'll show us different colors on the stock depending on how much material is remaining. Now, I may not have the workpiece set up correctly here. Let me redo that. Because what it should show is mostly everything being green, showing that everything is cut to size. So if I run through the roughing, the finish, operations here, and then I load those colors back in. So if I hit refresh next to this deviation page, it'll show us everything in green here that is cut to size with a cut tolerance of plus or minus 8 thou. Everything down at the bottom here, this needs to be flipped over and cut off afterward. The teal here being 8 thou up to 26 thou remaining down at the bottom there. But it's a great verification tool to make sure everything is cut to size before we run it on the machine. I think one other thing in simulation we can take a look at in our previous part file that can be really helpful is we'll take a look at saving it as an STL file for our from our simulation, and then we can also take a look at that steep shallow toolpath before we end it here today. So I'm just doing the facing operation again here and the advanced roughing operation. So if I run through the simulation, I run through simulation here, and I go down to the bottom right here, we have this blue tab for, nope, sorry. It's the yellow tab that says Cut Sim, and you can see this floppy disk icon here to save the stock. We can save it in my downloads here as whatever name I want it as an STL file. Now I can save it as an STL file to 3D print it if I want, or I can go back into Bobcat. I can use that as my initial stock, or I can go into a 3-axis milling operation, select how I want to machine it, and all that good stuff. I'm just going to do an advanced rough. You can see down at the bottom of this advanced rough operation, whoops. Down at the bottom here of this advanced rough operation, I can I can expand an operation, and we have this operation stock. So this is a great way to save time in terms of cycle time here by selecting that STL file in my downloads. And then now you can see the highlighted pink here. This is the material loaded in from my simulation, and it's telling the software this is how much material is remaining from that previous operation, and now it'll calculate from that stock versus my initial stock. So it's not going to do any air cutting, it's just going to recognize this as my operation stock, my stock for this operation, and it'll compute the toolpath based on how much material is remaining there. So it's a great operation stock, is a great way to save your stock of where you've left off at and run your cycle times from there. Other than that, also with that cut sim to save your stock, you could also, for example, if you want to do a threading operation, you could do your threading operation right here, and then you could save that part file as an STL file. It'll have that thread in there. So if you want to 3D print a thread, it's a great way to save an STL file and 3D print a thread there. So I'll get rid of that feature there, and we'll go to what we're going to finish up today here with that steep shallow, a newer operation that we have here. Instead of doing the advanced sea level finish that I'm deleting here, and instead of doing the flatlands operation that I'm deleting here, we can do it all in one fell swoop here with this steep shallow tool path. Setting up the tool here and our cutting feed rate and all that stuff. And we're doing a Z-level tool path on any tapered walls and along any flats, and setting our depth of cut and step overs settings there. I'm gonna maybe divide it by 2 to make it look a little better there. In simulation, we're setting the allowance to 0 because we're not doing an additional finish pass there. We're just going to plunge down in with the finish operation, linking, gouge check, advanced feed rates, and MDI we didn't go over today, but MDI just stands for manual data input. This is one we've added in to add any miscellaneous G&M codes. If we wanted to add a dwell time, wanted to add a spindle command, or if we wanted to add any raw text. If we wanted to add a comment, I can click on raw text here, select before or after operation, and then add that command in. You can enter anything you want here as raw text, or if you click comment, it'll add parentheses before and after. This is a test comment. You'll see this at the end of the G code there. And compute that toolpath there. So that's our steep, shallow toolpath going all the way down to the sides there. And we can take a look, if I turn it on here, take a look at it in our simulation. That's a great toolpath. Again, it's sort of 2-in-1. You've got a Z-level finish operation for any tapered walls, and for any vertical walls or flat horizontal areas, you have either a planar or an equidistant toolpath to follow along there. Follow along the 3D model that you have here. So here's our last Z-level finish, and then the steep shallow toolpath. And that's that steep shallow, sort of doing the equidistant around. Oh, now here's a good example of our collision. So everything here in red is showing that the tool holder is hitting there, showing that the tool isn't long enough. So it's a great way to make sure everything is good with the machining process there. If there's anything in red, normally it has a pop-up saying there's a collision between the tool holder and the stock. I've turned that off, but there is a pop-up option for that as well. Yeah, if I finish this up, we can see that I should get all of the tapered walls here at least. I want to see that part of it. So that's pretty good. The steep shallow, other than the tool not being long enough on the ends there, it will follow along the side walls if we need to, cut that to size, and will follow along any tapered walls and any flat areas with an equidistant tool path to give us a better surface finish there. Close out a simulation. And if everything looks good with that, we can go back in, we can change our tool there to make it longer. Right here, change the flute length and the overall length of 3 inches there. And once we verify everything looks good, we can go to the top and go to post. It will generate the G code here on the right-hand side. I can right-click on it, actually go down to the bottom and see that test comment there. This is a test comment. I can right-click on the G code, go to Save As, and save it as an NC file. Put it onto a flash drive and send it over to the controller. And I can also right-click, go to NC Editor for any RS-232 communication as well. And we can go over that in another seminar, in another webinar there. If you guys have any questions on that, please let me know also in the comments section, what you'd like to go over for next webinar. It is going to be, let's see, that's going to be not Wednesday coming up, but the Wednesday after. It is every other Wednesday, so it'll be on May 8th. And so if there is anything you'd like to cover in the next webinar, please let us know in the comments section. We'll also be sending a survey to see what you guys think for the next webinar, because we want to make sure that these are tailored exactly to fit your guys' needs. You guys have any questions in the software program, any help with that, we want to make sure we can help with these webinars. But yeah, other than that, that is all I have today for the advanced roughing and controlling your feed rates. We went over some awesome options in the advanced roughing here to set your adaptive roughing for high-speed machining. Under options, setting a rest machining option so that you're not air cutting, your operation stock so that you're not air cutting, and then also under the advanced feed rates, your adaptive feed rates here so that it will keep a constant chip load. You can take a look in the roughing operation here in the G code. If you guys can see it here, I'll expand it a little bit larger so that when it's getting into a corner here, you can see on each line of code, it will set a different feed rate to keep a constant chip load. All the way up to 120, all the way down to 8 inches per minute. It's only going to slow down a little bit in the corners there. But yeah, a great way to control your feed rates there with your adaptive feed rates in the 3-axis Pro tool paths. But yeah, thank you guys for viewing our webinar today, and hope to see you guys next time, May 8th. And let us know what you want to see in the next webinar. We'll be sending out an email blast to let you know what that one is soon, and hope to see you there. And thank you for taking the time out to check out the webinar today. Hope you guys have a great rest of your day. See ya.